In this problem, 2x plus 3 is a factor of this polynomial. And in part A, we need to show this expression, which is given below, is equal to 0. So we know, according to the factor theorem, if we have a factor of polynomial, which in this case is 2x plus 3, is a factor of this polynomial, if we set it equal to 0, therefore the value that we get, minus 3 over 2, this value is one of the roots of this polynomial. So when it's one of the roots, that means if we substitute that value in the polynomial must be equal to 0. Okay? So we will do the same thing here. We just replace x with the value that we have already found, which is the root of this polynomial. So it will be, in this case, 2 minus 3 over 2 to the power of 4 plus a to the power of 2 plus 1 times minus 3 over 2 to the power of 3 minus 3 times minus 3 over 2 to the power of 2 plus 1 minus a to the power of 3 times minus 3 over 2 plus 3. That must be equal to 0. So now we first raise the values in the brackets to their power. So therefore we will get 2 times here is and meanwhile I will expand the brackets or the parentheses. 81 over 16 minus 27 over 8 times a to the power of 2 minus 27 over 8 minus 27 over 4 plus 3 over 2 times a to the power of 3 minus 3 over 2 plus 3 is equal to 0. So I keep simplifying it. It will be 81 over 8 minus 27 over 8 times a to the power of 2, and I need to add these two up together, and I will get minus 81 over 8, and also I will write this one here, this term, 3 over 2 a to the power of 3, and I will add these two up together. I will get 3 over 2, right? It is equal to 0. Now this terms, these two will be cancelled out with each other, and then I will rewrite the equation in this way. So I will put first this term because it has a higher degree power. So I will write it 3 over 2 a to the power of 3 minus 27 over 8 times a to the power of 2 plus 3 over 2 is equal to 0. So looking at the coefficients of this equation now we see the coefficients of fractions. So in order to get rid of these fractions, we need to factorize. So I will factorize by 3 over 2. So let's say 3 over 2, I will factorize and I will get a to the power of 3 minus 9 over 4 a to the power of 2 plus 1. This equal to 0. Okay. Again, I will see there is another fraction which is the coefficient of a to the power of 2. So I want to get rid of all fractions. Therefore, I will multiply both sides by 4. Which will be 3 over 2 times 4a3 minus 9a2 plus 4 is equal to 0. Yeah. So as you see in this equation, 3 over 2 cannot be equal to 0 because it's a number. Therefore, we conclude that 4a to the power of 3 minus 9a to the power of 2 plus 4 must be equal to 0. Because this multiplication will give the 0 product. This is the product, will give us this product. So therefore this expression must be equal to 0. This is part A that we proved already, how this expression is equal to 0. So let's say part B, we are supposed to find the values of A. What are the values of A? And since this is a cubic expression, we have three possible values for this equation. In the previous video, we talked about how to factorize and how to simplify or find the roots of a cubic expression or a cubic equation. By following those steps, we will get to this point, so we can simplify this equation into this, the following: a minus 2 times 4a to the power of 2 minus a minus 2 is equal to 0. So then this from here I will get a is equal to 2, and for this expression, for this part, I will use delta. Delta is equal to b2 minus 4ac, and a here is 4, b is minus 1, and c is minus 2. Will be equal to 1 minus 4 times 4 times minus 2, which is equal to 33. So then I will get a is equal to minus b plus minus square root of delta times 2a divided by 2a, which will be equal to 1 plus minus square root of 33 over 8. So this is actually, there are two, because one with positive and one with negative. These two are also another two of possible values of A.